Hello guys, my name is Arun and welcome to my channel. This series is a series of tutorials on scientific programming using Python. Now, in the last tutorial, we saw some of the basic data types of Python, some basic elements of Python programs and everything, and how data variables in Python can be modified based on the data type. Okay, now we will be looking a little more extension of it. We'll be looking at here. We'll be looking at the operators, the advanced operations and everything, and we look at that slowly here. Now today, first thing we look at is the operators. Now Python programming language has a very rich set of operators. Now some of them are extremely simple and very commonly used, like addition, subtraction, multiplication, division. Okay, they are given by the standard programming symbols plus, minus, asterisk and forward slash. Okay, Python. Other than that, Python has other advanced symbols for as well. You have this operation like a plus equals b. Okay, this is actually called as increment addition. So let me take spider and explain this to you. Now let me set a equals 5, okay, b equals 6, and then let me type a. Okay, let me enter a few blank lines so that it's easy to follow. Now a plus equals b. Okay, now let me print it. Now I set a to be 5 again. Okay, now let me plus a equals a plus b. Now I print a. Now if I were to run this, let me just look at what happens. I select all this, run the selection command, and that's it. It prints 11 on both times. Now what happens is that this symbol plus equals is analog. This entire expression a plus equals b is analogous to a equals a plus b expression. Similarly, I mean this is actually, if you want to call it, you can call it as an increment addition operation like that. Okay. Similarly, you have an increment multiplication, which is given by a star equals b, which is actually analogously equal to a equals a star b. Okay. Similarly, you have an increment subtraction given by minus equals, and an increment division called as, or successive division, whichever you call it, given by slash equals. Okay, these are some new operators available in Python. Okay, other than that, you have an exponent operator. Now, unlike some programming languages where you have the exponent to be given by the caret symbol, or the symbol that is on top of 6 in your keyboard, in a standard keyboard, instead of that symbol, the exponent is actually given by your double asterisk symbols. Okay, it's given by double asterisk symbols. Okay, and that's one thing you have to keep in mind. This is kind of similar to that of Fortran programming. If you guys know what Fortran programming is, then you'll understand this easily. And these symbols are actually kind of inspired from C programming, because these operations are available in C programming. And you have parentheses. Now this circular parentheses are actually used for separating your expressions, your computational expressions. Okay, and your modulus operation, which is given by your percentage symbol. Now what this modulus operation does is that it just gives a remainder of your division. Yeah, let's say you divide a divided by b. Okay, now it will give a quotient, and it will also give a remainder. Now if you want the answer of the division, use this symbol. If you want the remainder, use the percentage symbol. And like that, you also have logical operators. Like or, and not. So instead of giving symbols, they usually Python directly uses the natural English words itself for the logical operators. So if you want to check whether it's a is this or this, now on a quick recall, in the sample program we saw earlier, Okay, I just looked at this. If n is 1 or 0, here when you're checking whether n is actually 1 or 0. So if you use here, this r is actually used as a logical operator to check whether this or that. Okay, related like that. So that's a logical operator, and is also a logical operator to see whether two conditions are simultaneously satisfied. And not is used for checking whether condition is broken or not. Okay, to check whether the negative of the condition is true or not. Okay, and then you have identity operators like is not to check whether if this value is this or this value is not this, like that at all. Okay, and similarly you have membership operators called as in that actually this is not in, it's actually is in, not in. These are the three membership operators. There are many others too. Okay, these are used to check whether this value is in this statement or like that. And now for to check the membership operators, you see this for loop over here for I in range 2 to n, meaning look do the for loop for the value of I inside this range 2 to n plus 1. So in is actually used for checking whether the I value is inside this range or not, like that. So so that's what it means. That's what it means here. That's what it means here. Fine. Now there are these are not the only operators. You have several operators available in Python. Okay, so you can have a look at it based on your need and application. Okay, and remember this rule, PEMDAS RELLOC. I mean, what it means is that if you have a lot of operators acting on in a complicated expression, the way it is executed is based on, there's a rule for it. First, the parenthesis, whereas the unary sign, the addition or plus sign or minus sign in front of the number is taken care of first, and then your parenthesis is taken care of first. Expression side, your parenthesis is taken care of next, and then your exponents are done. Followed by that, your multiplication, division, addition, subtraction operations take their priority. And after all these are done, your relative operators take the next priority, and then your logical operators take care of the next priority. So if you want to remember PEMDAS, there's a rule called as, there's a mnemonic, people call it, please excuse my dear Aunt Sally. Funny, right? They use that. Standing for parenthesis, exponent, multiplication, division, addition and subtraction. Okay? There are many more operators. You can just have a look at it based on your need. And then let's look at some advanced operators type, like lists. Lists are actually mutable multi-data type arrays. I'll explain what it means. I'll explain the concept of mutation in a few minutes. I'll explain what a list is. It's actually a multi-data type array, meaning it's an array which is actually a collection of multiple data. Okay, and and all these data can have different data types. And that is the reason why it's called as a multi-data type array. Okay, so if x, y, z and l, all of these are lists. Okay, and all of these, if you look at these, all of them have different data types except for x, which is just plainly integers. Y is actually a collection of integers as well as floats. So integers as well as floats. Z is a collection of integer, float, logical and strings. L is again a collection of that. Okay, and lists are mutable, meaning you can make memory manipulations to it. Okay, and this can be a single leveled or multi-leveled. What I mean by multi-leveled is that you can list support lists within them. For instance, if you look at x and y, all these are single row of lists with all the individual entries being being single valued numbers. On the other hand, if you look at z, the third entry, the fourth entry is not a single value, rather it's a list itself. So having a list inside another list, that's why you call it. So it's a double leveled list. Okay, whereas L is actually a triple leveled list, because you have a list having a list, and that list has another list inside it. So you have two levels of inner list available in an overall list. So L is actually a triple level list. Now based on this, if you can go on multiple levels of list within an overall list. So that's why it's called as a multi-leveled data type. Okay, and if you want to make a list, write the values, separate them by commas, and enclose them within square brackets. Square brackets. Okay, and list, that's what I mean here. List allow list within themselves. So the indexing goes from 0. So by that logic, the first value of the index of 1 is actually 0, the index of 3 is actually 1, the index of 5 is actually 2, for 7 it is 3, 8 it is 4, like that. For y it is 0, this is 0, 1, 2, 3. For z and l it's a bit tricky. I'll explain this in the next slide. Now I'm having the same values over here. Okay, let me copy all this. Okay, sorry, let me copy all this. Okay, come to Spider. I'll paste them up, and now let me run all this. Well, actually I can paste them in the console directly, but this is kind of easy because the console kind of easy. So this is done. If you look at the variable explorer, you have the list ready, L, X, Y, Z and L to be ready. Now what I do is that go to the next part and let me print the first 4. Copy all this 4, print them, copy them here, and then let me select them up, run them here. When I print them, X is printed as 1, 3, 5, 7, 8, and Y so on, Z so on, L so on, not a problem, it just printed nicely. Just like how we entered, it gets printed nicely. So it's not a problem. Now let's look at the indexing. Now in this case, if you keep these values in mind, if I just print X of 0, it will print 1, because as per the index, since the index starts from 0, this is the value 0, 1, 2, 3, 4. So X of 0 is actually 1, X of 1 is 3, X of 2 is 5, X of 3 is 7, X of 4 is 8, like that. Okay, now like that, like that, if I print X of 4, it will print 8. So 8, that's not a problem. Now let me print that case. Here the values are like only 3 entries or 4 entries, but there are only the indexes go from 0 to 3 here in Y. So if you print Y of 4, this will throw me an error. Okay, now let me copy this. You know what, it's just simple, let me type this directly. Okay, hold on. Now where am I? Yeah, print X of 0. Know what, I'll type it directly. Here, print X of 0, 1. Just use the up arrow key to access the previous commands, like this. Okay, like this. Okay, now if I print X of 4, it prints 8. Okay, not a problem. Now if you print Y of 4, but not that, Y has only 4 entries, so the last index is 3. So I'm telling it, the compiler, to print, the Python console to print a value at the 4th index of Y. When that, it gives an error stating that the list index is out of range, because there you have only 3 indexes. So if you want to access something that is beyond the scope of Y, you're not in a position to access. Now the interesting part comes from Z. Now if you look at Z, then let's go with the indexing. This is 0, 1, 2, and on the 3rd index you have a list. Okay, so by intuitively, if I were to print the value, what I have to do is that I just have to print the Z, and then now if I want to print an element in this list, so this is 0, 1, 2, 3. Okay, and in that, since I have a list here, if I just print Z of 3, it will print the entire list. entire sublist. Okay, now if I were to print something within that, if I want to print 6, what I have to do is that I just have to type 1, print z3 1. If I do that, it will print 6. It's because within this list 6 is actually in the second position. You get it? 6 is actually in the second position. As a result, if you want to print 6, you have to type 3, and inside the 3 you have to in that the second reference goes from 0 1 like that. Like that for L. If I want to type 3 here, let's count the values. This is 0 1 2 3, this is 2 3 4. So I need print L of 4. Okay, in that we're in the fourth entry, and in that entry is a list. So let's count it again from inside 4 comma 0 1 2. So I need list of 2. To print that, it's again a list. So I'm getting printed 3 printed here. Okay, and now since this 3 itself is a list again, what I want to do, if I want to print the first entry in here, what I should do is print 3. Print that, you get it. Not only that, there's another option. If I print like say 2 over here, it will print me R, because in this string the third entry or the second index, the value of the second index is R, so it prints me like that. So this is this is the feature of list. Okay, let's go back to the presentation. This is the feature of list. Similarly, tuple is actually the twin of list. It does exactly the same thing. There are only 2 differences. One, tuple is immutable, and second, tuples and end and begin with circular braces. Okay, and then other than that, the indexing and everything all are the same. All are the same. Now if I were to do the same exercise again, I'm not repeating it again, it's kind of the same. If we do the same exercise, we'll get the same answer. So it's not at all surprising. Okay, and now let's look at the difference between tuples and list. The major difference between these two is mutation. Now, what's mutation is this. Since variables in Python are kind of objects, sometimes multiple variables point to the same memory locations. Okay, now for this let me show you this example. Now x is assigned to a value 4.5 comma 6.7, a two valued list. Now I say y equals x. So because of this, y is inherently a list whose values are again 4.5 and 6.7. Okay, now by default y and x and y have the values 4.5 and 6.7. Fine. Now what I do is that if I were to append the value of list x with just with 1, meaning I just add one more entry to the value x, and that one more entry is 1. Okay, let me print the values of x and y. You see, by logic you should expect the value of x alone to be changed but y to be remaining constant, but it does not happen. It won't happen. Watch this. Now I copy all this, copy this, go to a spider over here. You know what, let me go over here, control paste this. Hopefully everything is printed. Yeah, enter. Now that's funny. If you see, I just modified only x, but y gets also modified. Now this is actually an example of mutation. Sometimes certain memory modifications done to one variable replicates in others. That is called as mutation. I just modified x. Since y's point is also made equal to x, so for some reason y gets also modified. Now this is actually called as mutation. Sometimes when you do certain memory modifications like this, the memory, I mean that kind of memory modification does not replicate in other variables, just like our conventional thought, and that is called as immutation. Or this is an example of mutation where the variables are mutable. Here the values are immutable. That's a stark difference between tuples and lists. Okay, now if I set, okay, I'll copy this and I paste in the console over here. Okay, now if I were to append one, it will throw an error because this tuple object does not have this append feature. So if I were to write print x comma y, it will be the same. Even if you do some other memory alteration, y and x will have you cannot modify it. I mean if you modify x, it will not modify y. To prove it, let me just change x to be 4.5 comma 6.7 1. Okay, now if I had to print x comma y, x gets modified but y is not. So this is an indication that the tuples x and y are immutable. However, despite mutation, there are certain cases wherein this mutation issue is avoided. Okay, that is, in switching data or making some manipulations to it without altering the memory. These kind of cases does not happen. For instance, here I set x to be 4.5 6.7 and then I set y to be equal to x. So at this level, both of them have the same value. Now I set y to be a different value. Okay, now I print x and y. Now if I do that, what happens is that x will retain the old value, whereas the y will retain a different value. Y will have a different value, but changes to y will not be reflected in x because I am assigning y to a new value or pointing a y towards another value instead of pointing to some other thing. As a consequence, nothing happens. Okay, on the other hand, let's try something different here. X equals 4.5 comma 6.7. Okay, y equals x. Fine. Now let me change. X equals 9 comma 7. Okay, fine. Now let me print x comma y. If you see, x is modified, it's present, but the modification in x is not reflected in y because of the assignment statement. Now here clearly the mutation is avoided. Fine. That's an advantage over here. Likewise, likewise, if you do the same operation with tuples, you will get the same answer. But still, for scientific computation, tuples and lists have a disadvantage. First thing, they have heterogeneous data. These are heterogeneous data arrays. Second thing, the sizes of them are not fixed. In scientific computing, it's recommended that we go with a very periodic or a very fixed data size, so it's easy for us to handle. Tuples and lists have other advantages, but for scientific computation, we need the data arrays to be homogeneous. So that's kind of a necessity. Okay, and all the data should have the same data type. So that is where our NumPy arrays come in handy. Okay, we'll come to that, and now let's go to dictionaries. We'll talk about dictionaries and typecasting here on the next, and a little bit of NumPy arrays, and the next tutorial we'll see on loops. Okay, now what a dictionary is that? A dictionary is actually a collection of primary and derived data types. It can be of any order. It can be of any order. To imagine this, imagine you have a wallet. You have a wallet or a bag. Let's say you have a wallet. In your wallet, you might have some cash. You may have your identity. ID card or some coins or a picture or some keys maybe, or some a few coins with you or anything. But the thing is, they may be packed, they may be kept in any order, it doesn't matter, but all of them have a tag. If you want to say, I just want to take a take a money take a cash bill, $100 bill or $100 bill or €100 note, €100 bill or anything out of it. Just say it. If it's available, you can take it. No matter how haphazardly it's placed, you can take it, isn't it? Like that, dictionary is just a haphazardous collection, not an orderly collection, but it's kind of a collection of variables and primary and derived variables. Okay, so here the indexing or the identification does not go by the number indexes; they go by keys and keys. Now, what are keys? Are actually keys are the names of the individual variables present inside the dictionaries. Okay, and the values that these variables stores are called as actual values. So we have two things: keys and keys and values. Keys are used for identifying the things in the dictionary, and values are the actual data being stored. Okay, keys are the identifiers, values are the data, and these data can be lists, tuples, dictionaries, integers, floats, logicals, strings, anything, so on and so forth. And these are actually used for consolidated data. For instance, this command, this line A, is a dictionary. Is actually a variable. It's a dictionary, and the values it hold, the variables it hold are actually v1, v2, and lst. v1 is integer value, v2 is another integer value, and lst is actually a list. So if you just say print A, it will print the entire dictionary. And note, the dictionary, the pattern and the procedure in dictionary is that you enclose the entire collection using curly braces or flower brackets. Okay, the keys are to be written as strings within single quotes or double quotes, and then you put a mandatory colon and write the value next to it. So this is a procedure. Write the dictionary within flower quotes, write the variable name in single quotes, write the data adjacent to the variable name using colon. So if you print A, it will print the entire dictionary. Print A of v1 in the v1, since v1 is a key, 6 is a data, 6 is a value. Okay, if you want to print the data 6, okay, you have to print A within brackets, square brackets, v1 in string form. Now this will print 6. If you print A of lst, it will print 5.8 comma hello, since it's a list. And if you want to print the first index 1 of list lst, what you need to do is that print A of lst with the normal notation, and then at the end you put other square brackets and put 1. Now this will print the first index hello, like that. That's about it. Now if you guys want to do this, copy this and paste it in your console, and you'll find the same. You can experiment with this. Okay, and two more things here. This backslash is actually used for line continuation, line break. Sometimes if you were to write a very long statement, and it might be preferable for you to write this in 2 lines or 3 lines and all. So to make sure that continuity is possible, what you do is that you put this backslash here and then continue this. This essentially means that though these two are separate lines, the Python compiler takes this as a single line because of this backslash thing. So it's not a problem. Okay, this is very useful if you have a very, very long set of expressions to be done and all. That's about dictionaries. We will come across the usage of dictionaries very elaborately in the future. And then let's look at typecasting. Now, typecasting, we always, as we saw in the previous example, in one of the earliest examples, typecasting is used for converting the data type from one to other, and it's very good and it's used for restricting data entry or making sure the data is only filtering the data entry and all. Okay, not only that, it's used for data conversion, and not only that, it also avoids mutation to some extent. Okay, for instance, don't worry about the first line, just importing NumPy module, but don't worry about that. What I'm saying is, what I'm doing is that I'm just making two variables, a to be a value of integer value 5 and b to be a list. Okay, if I print integer of a, it will print 5. Again, the type will show that it's an integer, and 5.0 as, and when it's a is printed as float, it prints as 5.0, it's float. And if it's character, it prints something, it prints a character here, but the data type is string. But if I print string, it as a string, it just prints as string and nothing. Bool means it's used for getting a boolean value, which prints as true and it's boolean. Like that, if I print b as a list, it will print b, it will print the value b, and it as a list, it says that the type is list. Like that, its value is made as a tuple and it's printed over here because of this typecasting. Likewise, np.array is actually used as a typecasting for converting any data into a numpy array. So if I use that, the value is modified and it's printed as a numpy array. Numpy.nd array is actually numpy as actually n dimensional array. That is what it means. Okay, now this is called as typecasting. It's used for converting data types. Okay, and finally numpy arrays. Okay, numpy arrays actually comes from the module numpy. See, if you look at the list and tuples, these have heterogeneous data types whose values are very can modify very drastically and all. So this kind of procedure is not good for the scientific computing. Like they have their own advantages, but this becomes a little tricky. This becomes a little tricky and a little harder. So what you do is that you need a data type which is homogeneous, whose sizes are fixed, which is not which cannot be dynamically modified. For those kind of things, numpy arrays are very useful. Okay, and also it assumes the data type automatically, but you can manually set it to, and needs numpy module to get these arrays, and the inputs can be lists and tuples. So what you do is that you just already define a list or a tuple, and if you want to enter that value into a and if you want that value to be made as a numpy array, you need to give it as an input. And to get a numpy array, you need typecasting. Otherwise, if you do not use typecasting, it cannot be done. Okay. Now this is a sample example. So let me copy this and run this for you guys. So this is a new example. I copy this and run this. Copy this, and I print it here. Okay. So let me enter a few lines so that it's easy for you guys to follow. Yeah, fine. Now, don't worry about this statement input numpy as np. I'll explain this in an upcoming tutorial, so it's not a problem. Just for now, imagine that we're using numpy arrays. If I run, okay, some error, not a problem. Okay, it just got messed up, not a problem. Yeah, run this. Okay, now let's look at the data. Now L is a list which has the value 5, 7, 9. T is a tuple which is again 5, 7, 9.7. So I set A to be np.array of L. I'm using typecasting to make L to be and I'm feeding the value of L to A as okay. Now L is a numpy array. The L is a list, but now A, because of this typecasting, becomes a numpy array. And if I look at the variable section over here, okay, let me clear all this up. Control Alt delete. Fine. Let me run this. I guess this should be available. Yeah. Yeah, perfect. Now L is a list and T is a tuple. It's written over here. Now A is an numpy array, but is taken to be an integer of type 64, meaning an integer which takes 65 bits of memory. And now B is taken as numpy array of floating type 64, meaning floating numbers which take 64 bits of memory. 64 bits of memory. Okay. Now let me save this. Yeah. Now why is this so? See, why L is taken as, why A becomes integer, B as a float? It's because if you look at all the entries in L, all of them are integers. As a consequence, NumPy takes the best possible match to represent all these numbers, and the data type that represents the best possibly all these numbers is an integer. So it takes int64 as a possibility as the data type. For t, it sees whether int can be done. Now with as int 5 and 6 can be represented, but 9.7 cannot be represented. It will be, so it takes it looks at float. Now float will represent all these numbers nicely, so it takes float as the data type. So when during the type conversion, it takes as float. Okay. Now when I print the type of L, T, A, and B, you get list, tuple, numpy array accordingly. Okay. If I print the data type of the individual entries, to get the data type, I need to use this command np.dtype. This np is because of numpy. The dtype is actual command. Okay. np.dtype on the actual values. Okay. All the values in A are integers, so I get int64, and all the values of B are floats, I get as float64. Okay. And now this is about automatic. This is how to use numpy arrays, and we will have examples wherein we'll be using them elaborately. Okay. Now another thing is, I told you that here that the data types can be set manually too, which is to do that you have to do like this. The data types are automatically allocated. You can use dtype inside the numpy array to set the data type manually. For instance, A equals numpy array of L, comma dtype equals np.float32. Now if I set this, now this will make A to be a float. So what I do here is that A, okay, let me use a new variable, C equals np.array L, comma np.dtype equals, okay, how did I write it over there? Yeah, my bad, sorry, my bad. And dtype equals np.float32, let's say. Let me run this up, run this. I don't know whether it ran or not. Okay, it ran. If you look at the file explorer, variable explorer, look at C is float32. Though all of them are integers, you're actually making it float. That's about it. Now okay, okay, I guess that's it. That's enough for this tutorial. That's all I have for you guys in this tutorial. Next tutorial we'll look at we'll look at the loops, the if clause, a little bit of functions, some slices, and the modules with that, some basic parts of Python programming are over, and then we look at some examples on how to do with that. Thank you guys for watching, and I'll see you guys in next tutorial then.